Welcome to our simulation. This video is based on the simulation of the 2 LED flasher circuit. So I'll start aligning my components from the left to the right. From left to right. So I'll start with my first diode, which is the diode D1, and first I'll start with D1. Okay. So in series, I'll put my resistor, which has a value of 470 ohms. And parallel to that, I'll put another resistor of 22 kilo. 22 kilo ohms. In between these two resistors, I'm going to add a capacitor. I'll rotate. Okay. This capacitor, I'll put 100. Let me just do this. Okay, 100 microfarad. Let me use some connecting just to make sure that I'm going in the right direction. So this will be the connection. This is my first stage of my circuit. Okay. I'll get another resistor, which I'm gonna put in parallel to resistor 2. In fact, let me just copy this instead of me going all the way out. So I'm gonna copy this resistor here. This is move, copy. I'm gonna copy this resistor of 200 kilo ohms to 22 kilo ohms. My bad. And I'm gonna copy this other resistor here. I'll put it in parallel to. Okay, so my connecting wires. Okay. In between these two resistors, I'm gonna get this C1. I'm gonna paste it here. It will be my C2 in connection to in series with my resistor R4. Okay, and I'll copy this diode, which I'm gonna put in series with my resistor R4. I'm gonna add some few connections. Okay, so for our circuit to be complete, I'll put my switches, which I'm gonna use NPN transistor. This will be my first transistor, and this will be my second transistor. So put the values of this. I'm using a type of resistor I'm going to use BC547B as my switches. Same applies to this resistor. Okay, so connecting my collector will be connected to a positive side of my capacitor, and my base connection will be connected to the opposite side of my C2. Same applies to this transistor. My collector will be connected to the positive terminal of my capacitor. My emitter will be connected to the ground. Okay. So let's put this. Okay. Let's show the polarities. Let's copy now. I want to move. Unit. So at this point, I'm going to get my supply. This will act as our battery. I'm going to put 9 volts as our circuit requires. I'm going to use the connection wires. Okay, so now we get our ground right there. We connect it to our circuit. So this is our complete circuit. So my running time I'm used to stoppage 0, and the maximum timer put 1 as desirable. So now I'm going to run my circuit. So here we want to check the amount of current which the LED is receiving. So now that I've completed my circuit, I'll run the circuit. So my aim of running the circuit is to see how much current is flowing through the LEDs, because I couldn't tell if they're blinking or not because of the system tool that I'm using for my simulation. So this is my current which is flowing through the LED. It's approximately about 17.0 milliamperes. Thank you.
Okay, so here I'm going to start with my circuit prototype. So I'm going to I'm going to draw the circuit on the board. Our circuit is 2 LED flasher circuits. Our circuit diagram is as follows. LED. Our main supply, 9-volt battery. This is Q2, collector, emitter, and this. Yeah. So this is our capacitor C2, 100 microfarad capacitance. So this is our circuit diagram. So according to our circuit, I'm going to do our prototype. Okay, so now I'm going to do the prototype of this circuit that I've drawn here. The two LED flasher circuit. That means that after my prototype, my circuit should flash. I should have my LED. My LED should blink sequentially. So here I'm connecting. I have two BJT transistors, NPN transistors. As from the circuit on the board, I'm connecting this. This is my emitter, base, and collector. So I'm connecting my emitter to this negative rail. As we know that the current that flows from here up to this 51 is the same. So I'm connecting another BJT, another BJT, 1, 2, 3, another BJT here. Similarly, from the emitter, I'm connecting it to the negative rail. From the collector of the BJT, I'm connecting 470 ohms. And this 470 ohms is in series with the light emitting diode. And I'm connecting the positive side of the light emitting diode to this positive rail, and the negative side is connected to this resistor. Similarly, to the other side, I'm connecting this 470 ohm resistor to the collector of the bipolar junction transistor, and I'm connecting my positive side of the light emitting diode to the positive rail, my negative side to this resistor. I'm keeping on counting these boxes because current that flows from here to here is the same, but there's a break here, so you should take note. If you exceed this side, you should put a connecting wire. So between we have two 22 kilo ohm resistors. Here I'm connecting them, 22 kilo ohm, and here comes another 22 kilo ohm. I'm connecting my 22 kilo ohm with this positive side. Similarly, I'm connecting this 22 kilo ohm again to the positive side. Now I'm connecting my capacitors C1 and C2. So the positive side of the capacitor, I'm connecting it to my transistor. So the positive side, I'm connecting it to my transistor, and my negative side, I'm connecting it my negative side, I'm connecting it to the 22 kilo ohm resistor. Similarly to the other side, I'm connecting the positive side of the capacitor here to the collector of the BJT, and the negative side to the negative side to the 22 kilo ohm. Now the last and the final part, I have to connect the base of the BJT to the negative terminal of the opposite capacitor. So here's the negative terminal that I've connected to the 22 kilo ohm. I'm connecting here. Similarly, I'm connecting the base, this is the base of this transistor, to the negative terminal of the capacitor, opposite capacitor, this one. So now my circuit is complete as per the circuit on the board. So now I'm connecting my source. If I connect my source, my light emitting diodes should flash one after the other, showing the function of my circuit. Yeah, this is what we are talking about. They are lighting one after the other. This is why we call it the 2 LED flasher circuit. So our prototype is done and our circuit is functioning. I thank you. So I finished my prototype and I have my circuit on the board. So here I want to do circuit explanation. So let me explain using the circuit on the board to make it clearer and easy. So our circuit is the 2 LED flasher circuit. So firstly, I'm going to tell you how our components are functioning in our circuit before I explain to you the functioning of the circuit. So firstly, we have a 9-volt battery, our power supply. So this battery is used to supply sufficient electrical energy for the circuit to run. That is the role of our battery. Then let me go to this resistor, R1 and R4. Both of them are 470 ohms resistor. These resistors, as you see, they are connected in series with the light emitting diode. So these resistors ensures that the diodes, the light emitting diodes, receives safe amount of current. Without R1 and R4, our diode D2 can receive enough amount of current which can cause them to to overheat and suddenly burn out. So resistor R4 and R1 are very important. Then we come here to our resistors R2 and R3. Both of them, as you see, they are 22 kilo ohm resistors. These resistors, as you see, they are connected to Q1 and to Q2. Their operation is to control the switching behavior of this BJT by controlling their base currents. Resistor R2 and R3. Then we have capacitor C1 and C2. Both of the capacitors are 100 microfarad capacitors. These capacitors, they introduce a timing delay, allowing the circuit to alternate smoothly between turn on and turn off conditions. So that is the role of C1 and C2. Now we have two BJTs, two bipolar junction transistors, Q1 and Q2. In our circuits, Q1 and Q2, they act as electronic switches. When one transistor turn on, the other one is off, controlling the blinking sequence of our light emitting diodes. So this is the role of our components. Obviously, D1 and D2 should turn on and off, showing our circuit operations. So this is the role of the components. So now I'm going to explain in brief or in short how our circuit works. Okay, when we connect the power supply in our circuit, we have 9 volts. When we connect the power supply, there's going to be a slight difference in our components in our circuit that is going to cause one bipolar junction transistor to turn on, allowing current. If this one turn on, it allows current to pass through to the corresponding light emitting diode. Simultaneously, the capacitor on the second BJT, this one, will start charging. ATCR will start charging when the voltage of this capacitor reaches a certain voltage. It forces the first BJT to turn off and turn on the other one, causing current to flow to the corresponding light emitting diode, making it to glow and light like what the first one have done. So this is how our circuit works. So this process will continue over and over again. Our light emitting diodes blinking one after the other. So with this explanation, I thank you.